Product rule is the rule to use that used to find the derivative of the function where it is in the product form of two different functions. If the function f and function g are differentiable and y is in the product form of the function f and function g, then the derivative of the y or dy by dx is the product of the f and the g prime added by the product of the f prime and the g, or in the shorter version is in the form that y prime is f times g prime plus f prime times g. The quick tip for this is once you identify y as the function as the product of the two different forms, make a list on your side notes for the function f and function g. You find the f prime, you find the g prime, and then you cross multiply. Like the function f will be multiplied by the g prime, the f prime will be multiplied by the g, and then you can form the formula for the product rule. Let's see examples. The first one, use the product rule to find the derivative. In part A, y is in the product of the quantity x squared plus 3x minus 1 and the quantity x to the third minus 8x. So we identify the first group as a function f, the second group as the function g. I'm going to make a note on my side. F is x squared plus 3x minus 1 and the function g is x to the third minus 8x. Find the f prime. Using the power rule for the first term, we get 2x, and the constant multiple function for the second term, we get 3, and the derivative of the constant, we get 0 for the last term. For the g prime, the derivative of x to the third, we get 3x squared. Derivative of negative 8x, we get negative 8. Now we get all the prep work done and bring it back to the main problem. Your goal is to find the derivative, which is the y prime. So y prime based on the formula using the product rule is f times g prime plus f prime times g. And then we just put the right expression at the right spot. For the f, we replace it with the quantity x squared plus 3x minus 1 and multiply by the g prime, which is the quantity 3x squared minus 8 plus the f prime, which is the quantity 2x plus 3, and multiply by the quantity for the g, which is x to the third minus 8x. So at this step, I'm done with the placeholder or apply the formula to find the derivative. The next step, I'm going to have to simplify the expression. So I'm going to distribute the 3x squared minus 8 to the three terms in the front. Then we get 3x to the fourth plus 9x to the third minus 3x squared. And then do the same when you multiply every term in the front by negative 8 to get negative 8x squared minus 24x plus 8. And similar way for the second group. So 2x times x to the third, we get 2x to the fourth minus negative 16 x to the second, and then added by 3x to the third, subtracted by 24, multiplied by x. It looks very tedious. And next step, we are going to collect the like terms or simplify like terms. So far we have 3x to the fourth added by 2x to the fourth. Combine these two becomes 5x to the fourth. And the next one, we're going to group the power 3 together. The power 3 has 9x to the third and 3x to the third. And then collect this term to give us 12x to the third. And after that, we look for the term with the x power 2. We have negative 3x squared minus 8x squared minus 16 x squared. So we get negative 3 minus 8, which is negative 11, minus another 16 becomes negative 27 x to the second. Next group gonna be the term of the x. So we have negative 24x, negative 24x, combine them to be negative 48x. And the last one gonna be the number. And so far we have only one single term as a constant, which is positive 8. And this is our answer for the y prime.